Hello everyone. Today I'm going to continue my O levels chemistry series and moving on to the topic that is the very first topic of O levels chemistry, that is experimental chemistry. So let's start. Well, in chemistry, it is very important to measure certain physical quantities. Now, the most important quantities that you're going to study in this course will be time, temperature, mass, and volume. So how to measure time? Well, a time can be measured by using a stopwatch, whether analog or digital. In the picture, you can see a stopwatch, analog stopwatch, to measure time. And the SI unit for time is seconds, that is denoted by a small s. Now, other units of time are hours and minutes. Uh, I assume that you know that 1 minute is equal to 60 seconds and 1 hour is equal to 3600 seconds. If you want to note that, please write it down. Right, so the next thing is temperature. How to measure temperature? The temperature is measured by using a thermometer, as it is shown in the picture. Now, the liquid inside a thermometer is whether mercury or alcohol. Remember that most commonly alcohol is used as liquid because it is harmless. So the mercury is a dangerous liquid and it is not used pretty much. So the SI unit of temperature is Kelvin, and remember that 1 degree Celsius is equal to 273 Kelvin. Now notice something here, that the liquid used in this tube is actually alcohol. But isn't it that alcohol is colorless? Then why it is blue line? So what is your answer? Think about it. I'll give you some time. So have you figured it out or not? Well, it is used, a color is used in this alcohol. A viewer can see the alcohol clearly, so it is easier for him to read the reading. So that's why a color is used here. Now, to measure mass, we either use the electronic balance or the beam balance. The SI unit for mass is actually kilogram, denoted by small k and g. Now, you might have seen this beam balance. It is not used now because it is old-fashioned. You put some weight here and you try to balance it here in order to get the reading. And this is an electronic balance. You simply put some thing that you need to measure over here and it will show you the reading right here, the 00 shown right in there. The next thing is volume. The next physical quantity is volume, and you're gonna study burettes, pipettes, measuring cylinder, and gas syringes, that are the apparatus to measure volume that is included in O-levels syllabus. Now, the SI unit of volume is cubic meter, denoted by meter cube. I'm sorry it is blurred because it's actually a picture of m cube. So sorry for the inconvenience. Moving on. Yeah, right. Measuring cylinder. Well, a measuring cylinder is used for approximate measurement. It can measure from 1 centimeter cube to up to 1000 centimeter cube. Now, how to take reading? You can see that when you see a liquid inside a measuring cylinder, the top of it is not flat, rather it is curved just like this. You can see this, it is a zoomed view, so it is curved. What is this called? Well, this is called the meniscus, right? If it is curved downwards, it is called lower meniscus, and it is curved up, and if it is curved upwards, it is called upward meniscus. It depends on liquid whether it is lower meniscus or not. Well, to read the reading, you need to take the reading that is at lower meniscus. The reading that is on lower meniscus is the reading of the liquid. This is only valid for colorless liquid. If the liquid is colored, then you should choose upper meniscus for the reading to get the accurate results. Now, what are burettes, pipettes, and volumetric flasks? Basically, these you will see in while attempting paper 3. Paper 3 that is related to practical procedures, and these apparatus are involved in titration. The first one, the picture you're seeing is of a burette. A liquid, mostly acid, is poured into this long tube during titration, the burette, and it measures up to 50 centimeter cube, right? And its least count is 0.05 centimeter cube for a single measurement. And you open this tap over here to pour the acid downwards into volumetric flask, which usually contains an alkaline material. The next thing you see in this photo is pipette. Well, pipette are used to take exact volume, and it is of 25 centimeter cube. Usually you will see in lab that you have a 25 centimeter cube pipette, and it is used to measure exact volume, not less than or not more than 25 centimeter cube. There's a line over here, so you're gonna fill the pipette right up to here so that you can get 25 centimeter cube in this case. The next thing is volumetric flask. Now, volumetric flask measures from 25 centimeter cube to 250 centimeter cube and 100 centimeter cube. It is used to make the solution of a specific concentration, and it is filled right up to this line. So whether the volumetric flask can measure a 25, whether it can be of 25 centimeter cube or of 100 centimeter cube or of 250 centimeter cube. So volumetric flask is used to prepare a solution of a certain concentration. The concentration might be anything. So these are the three apparatus used in titration. Yeah, the next thing is gas syringe. Well, it is important to determine the rate of the reaction, so that is why this flask is carrying a chemical reaction. In the bubbles you can see a certain gas is produced, so the gas rises and collects up to this gas syringe, and the gas syringe collects it, so you can know how much volume has been produced of a gas. Now, as I've told you that collection of gas is important because it is used to determine the rate of reaction or its progress. Now, the collection of gas is determined by two major factors: density relative to air, the density of a gas, certain gas, relative to air, and solubility of a gas in water. Now, these are very important factors of how you can collect a gas. Let's see the methods of collecting a gas depending on its density and its solubility. Right. So the first method you are seeing here is called downward delivery method. A gas enters from here and it just runs down and collects into this jar or beaker or tube. So now This is called downward delivery method. Why? Because it is used to collect the gas which is heavier than air. So when the gas will be heavier than air, it will come and just go downwards and will be collected. If it was lighter than air, then this method could not be used, and it uh, runs from here, the lighter gas, and just escapes from the jar because of the lower density. For lighter gases than air, where the density is low, we use upward delivery method. So when the gas, lighter gas than air, enters from here and it collects at the top of the jar. So upward delivery method is used for gases that are lighter than air, and downward delivery method is used for the gases that are heavier than air. Now this method is used if the gas is insoluble in water. Now the gas runs from here and it enters at the bottom of the tube, and because the gas would be insoluble in water, it collects at the top of this jar, so getting a, a gas. Now moving on to next slide. Yeah, so what is a drying agent? Well, we need to collect a dry sample of a gas, and in order to collect a dry sample of a gas, need to pass it from a certain drying agent that is used to dry the gas, and it can be collected without water vapors in it. Now, in this case, a moist HCl is passed into it, and this tube is synced into concentrated sulfuric acid that actually is a drying agent. So these bubbles came upward, and now it escapes as dry HCl, as all the water vapor have been soaked in by concentrated sulfuric acid, that is our drying agent in this case. Note that the drying agent used depends on three main properties of gas. For example, if the gas is acidic in nature, we use concentrated sulfuric acid. But what if the gas is alkaline? Well, then we don't use sulfuric acid because it will react with sulfuric acid because of its alkaline nature. Instead of using concentrated sulfuric acid, we use calcium oxide. Calcium oxide for our gas. The third case would be if the gas is neutral. Well, if the gas is neutral, we simply use calcium chloride because it will not react with the drying agent. Now, this table is important for you. You should memorize it, the properties of common gases, because it will help you in solving your paper 3, that is practical paper, and it is a very useful table, so you should memorize it in order to get aware or get good marks in paper 3. Now, well, how the rate of reaction is determined? As I told you that the rate of reaction is determined if we collect gas and measure the volume of it, but there is another method as well. We can determine the rate of reaction by simply determining the chain mass. Now how is that? A reaction goes here in this polymer flask. When the gas escape, there will be change in this electronic balance, change in the reading of this electronic balance because of the gas escaping from here. So from this phenomena, we can plot the graph of time by using a stopwatch and mass of the flask on y-axis. That will give you this curve. Right? This is called the mass loss curve. So you can see that as the time progresses at x-axis, the mass of the flask is decreasing because the gas is escaping. At a certain point, it will be constant. Why is that? Because there will be no change in mass. Why is that? Because the reaction is fully occurred. That means the limiting reagent is completely used up, and there is no more further chemical reaction. So the initial gradient gives the initial speed of the reaction, and that's how we determine the rate of the reaction. So thank you, class. This was the first video of O-levels chemistry. and your suggestions and will be very important for me, knowing that whether my videos are helping you or not. You can help me with your suggestions in comment section, and any improvement you need or you want will be appreciated. So thank you, and see you in the next lecture. It will be coming soon. Thank you.